guys were basically given linear, quadratic, and cubic. Class, linear has what degree? 1. Quadratic? 2. And cubic? 3. What are some similarities and observations you guys made? Anybody? Yeah.
Linear and cubic are odds.
Linear, so similarities, that's a symbol for similarities, back in Math 4. Similarities, linear and cubic are similar. Okay, anybody else? Differences is a delta, that's a triangle, it means change. Anybody else? Someone from Harvard taught me that. That's all they taught me. Shouldn't say that. No one else? Okay, how about this one? I noticed that the most amount of x-intercepts is associated with their degree. Count with me. Ready, set, go. Count with me. Ready, set, go. So this one is 2. This one is 1. How about this one? Does it touch the x-intercept? No. Okay, so here we would say 0 reals and 2 imaginary. So if you add those together, what do you get? 2. This one says 1 real, but they call this a double root, which basically means it's 1 times 2 is 2 reals, so 2 reals. Did you have any imaginaries? No imaginaries. So 0 plus 2 is? 2. So this is really the big idea. Let's tell you the answer. Is the degree, let's do with blanks. So blank equals blank plus blank. The degree equals the real zeros plus the imaginary zeros. Let's draw a really big box around that. It's a formula you can use. And essentially, if you want to know what that is called the fundamental theorem of algebra. Fun, because math is fun, fundamental theorem of algebra. This kind of gives us hints. Watch how I can use that. Class, a cubic function has to what degree? 3. Okay, so I know my answer has to be 3, right? This one, it says it crosses the x-axis how many times? 1, 2, 3. So that means that this number of imaginaries has to be what number? Something plus 3 equals 3. 0. Do you see that? Let's try another one. You guys do the rest of these. 1 real times 1 is equal to what? 1 real. 1 real times 2 is 2 reals. 1 real plus 2 real equals 3. And how many imaginaries would you have? 0. Okay? I want you to go through the rest of those and kind of do that simple math operation with this. You have these symbols, similarities, differences. Can you give us one of those? Yep. Okay, question. Sum cross x-axis. When it crosses the x-axis, what is that called? Oh, you're saying y-axis. Okay. Question. Can you tell me which ones do not cross the y-axis? So we can say all of them cross the y-axis. Okay, Camille, pick the next person. Okay, so they all have arrows. So they're all polynomials. I'm hoping we talk about this, so let me just reference what it is. A real zero is where it crosses the x-axis. Class, what's a real? It crosses the x-axis. So what do you think a imaginary is? An imaginary does not touch the x-axis. The graph does not touch. Resolve to pick the next person? Oscar? No observations? I noticed that those that don't have the word multiplicity equals the number. So let's go ahead and fill in the box. Class, linear means what number? You would put a 2 in there? What number, class? 1. Linear is x to the first power. Quadratic? 2. And cubic? 3. So another similarity is that those with no multiplicity equals the degree. So no multiplicity equals the degree. Anyone notice any differences? Oscar, you raise your hand? I noticed that I noticed that all of them actually have both real and imaginaries. Go ahead and copy this box I'm about to draw. But some of them don't have reals and some have just imaginaries. So the degree is equal to the number of real zeros plus the imaginary zeros. And I'm just going to call this the fundamental theorem of algebra. Let me show you how this works. Let's go to this one right here. Class, what's the degree of my function? 2. So I know the answer is a total of 2 zeros. This one has 2 reals. That means the number of imaginaries. Something plus 2 equals 2. So class, this number is 0. 0 plus 2 equals 2. Let's try the next one. This one says 1 real with a multiplicity of 2. Class, what's 1 times 2? 2. So I have 2 reals. My total is 2 because the degree is 2. And class, how many imaginaries do I have? 0. 0 plus 2 equals the 2. From the degree. Let's try one more. And then I want you guys to do this little math equation for the rest of them, okay? Class, this is a quadratic. What's its degree? 2. The degree is 2. Well, I have 2 imaginaries, so how many reals do you have? Something plus 2 equals 2. 0. Partner A, I want you to explain this example using the equation we did in the blue box. Partner B, I want you to explain this example, and then I want you to do the rest of them. Question? So I multiplied it. 1 times 2 gave me the 2 reals. So the rest of you guys, with your partner now, fill out the rest of those. Ready, set, go.
So there's 0 imaginary on the first one. There's 0 imaginary stuff that touches and so there's 2 real distinct numbers. And the intersection is like that and that. So that could be like anything. So 2 boys, 2 of those, 2 real zeros plus 0 imaginary zeros. Yeah. And then on the next one, there's 1. Wait, on the site, wait, how do you get 2 on the site? There's 1 real number, but why do you multiply it by 2? Why do they say
The answer is that if you make up a number on the x side, like 3, it should be real. And x equals 3.
So if you have one,
And that's why it's all of them.
then you don't need another one.
I'm going to have to teach you guys all of
So
them.
now if you multiply and
Basically, just adding the real zeros and the imaginary zeros.
And then on the last
You guys are
one,
doing the plus.
there's 0 real numbers and there's 2 imaginary.
You're doing these for all of them,
It doesn't
guys.
touch the x-axis.
Do it for all of them.
Oh.
So
now you have
yeah,
one.
it's just-
So this one could be
okay, and then on this one, so this one has 3 real zeros since they intersected the thing 3 times. And do I have any imaginary ones? So this one's 3. I think this one, this one and this one. I would like this one and this one.
Let me know when you're ready. You always get detentions in pairs.
Wouldn't they all be the same?
You ready, Angel? How much time you need? But I did all of them already. Yeah. Can you pick one of the cubics? First, second, third, or fourth one? Okay. All of these will equal what number? All of these will equal what number? What's the sum, Angel? 3 is correct. So whatever the degree is, that's what you're writing there as your sum. That's the end. Okay? So Angel, if I have 3 reals, how many imaginaries do I have? 0. Raise your hand if you got that. Okay? Angel, pick the next person. Oh, you got to do 2, right? Pick another one. Okay? What does it mean to have 1 real with a multiplicity of 3? Do you want to pick another one? Yeah, you multiply it by 3. So how many reals do you have? 3 of them. So how many imaginaries do you have? Correct. And then what number do you write there? Because that's your degree. Okay? Angel, pick the next person. Alright, Resolve, we got 3 more in here. You only have to do one. This one? How many reals? Imaginaries? And that equals 1, because your degree is 1. Pick the next person.
Oscar.
So 1 real.
And then plus 2.
Yep,
Plus
1.
2 reals, which is 3 reals.
Question. How many imaginaries do you have then? 0 imaginaries. 0 plus 1 plus 2 gives us 3. Oscar, pick the next person. Fidel, this one? Equals what? 3 degrees. Okay? So this should give us a lot of hints about our answers. Let's answer the question at the bottom. Fidel, pick the next person. Joseph, this one? Read it out loud.
Describe the number of graphs of each function you could sketch given the combination of 0. Explain the reason.
We can sketch infinite, unlimited amount of graphs because the zeros shows us where the graph crosses the x-axis but not things like extrema or end behavior. We can sketch a limited amount of graphs because it just tells us where it crosses specifically the x-axis. But it doesn't tell us like the extreme or how high that graph goes, how low it goes.
You don't love math? What's wrong with you?